We are at the end of the year. Aren't you excited? So we have one more test that's going to come up, and this is the final real chance to improve your grade before the school year ends. Now, here is a review of the material that's going to be on the test. I believe you're only going to have one chance to take the test, so go over this review a couple times and make sure that you understand every process of this. Now, if there is a question that you are kind of iffy on, go back and look at this video again and that specific part. That way you could really understand what's happening with that question. And if that is even harder, then go back to the original lesson. I am going to go through these questions relatively quickly with pretty short explanations. I'm not going to get too much into it. There's videos already available that have taught the material. So let's get straight into it. Now, this first one is, which of the following shows 150 degrees in standard position? Now, the best way to think about this is to first draw out our unit circle here and think about what each of those slices actually mean. Now, we're dealing with degrees here, so we don't have to think about it in radians, but we have a whole circle being 360 degrees. Remember that. So this is going to be 360 degrees. That's when it goes all the way around the circle, which means if we cut it in half, that's going to be 180 degrees. If we cut that in half again, we would have 90 degrees. And if we take 90 times 3 to get to the third point, we'd get 270 degrees. So that means 150 degrees is going to be somewhere between 90 and 180. So we would be looking for a graph that has it there and an arrow that goes to that point. So do we have one that looks like that? Yes, we do. It would be this one right over here. So that is the one that we're going to select. Question number 2, what does the 5 represent in the function below? Now, each of these mean different things: amplitude, frequency, phase shift. If we remember, amplitude is going to equal the absolute value of A. The frequency is going to equal 1 over the period. And then the period is going to equal 360 divided by the absolute value of B. The phase shift, that is going to be our H value on the inside. And again, the period is going to be 360 divided by B. And all of these come from our general form of these trig functions, which in sine's case is A sine of B theta minus H plus K. So as we can see, the A here represents the amplitude, so that would be our answer. All right, so here we have question number 3, which has the same value as cosine of pi over 3. Now, there's 2 ways that we can go about doing this. One involves understanding where it is on that unit circle that we briefly talked about, or the other way is to use Desmos. Now, if we're going to do this by hand, I'm going to get something that we built in a few lessons ago. And that is our trig table. Now, I just went ahead and looked it up online, and here we have it, our trig table. Those dashes mean undefined. Now, if we look at the top, we have our radian degree measures, and then if we look at the second line, we have our degree. And then we have sine, cosine, tangent, and cotangent somehow just made it onto this list. I don't know. But if we're looking here, we're looking for cosine of pi over 3. So let's look at the list. Cosine of pi over 3 equals 1/2. So this is going to equal 1/2. So now we need to know which ones of the other ones also equal 1/2. Now we could do that with reference angles. And if we have a reference angle in a spot that is going to give us a positive measure, then that's going to be our answer. So for instance, 2 pi over 3. So that is taking our pi, dividing that up into 3 pieces, and then using 2 of them. So our reference angle is actually going to be equal to pi over 3. But the problem with this is that if we write out all students take calculus, then that top left portion there is going to be a negative for cosine. So this is going to equal negative 1/2, and it doesn't work. Pi cosine of pi, that doesn't even have a reference angle because that just goes onto the circle axis itself, so that's not going to work. 4 pi over 3. We could try that one, but I have a feeling that it's going to come out short somehow. So this is going to be pi divided into 3, so we're going to divide the top into 3 and the bottom into 3, and we're going to use 4 of them, right? 1, 2, 3, 4. And so our reference angle actually is pi over 3 again. So this is going to be pi over 3 as a reference angle, which we do know to equal 1/2. But again, if we use our all students take calculus, in the bottom left, tangent's the only thing that's positive there, so this is going to be a negative. So that doesn't work either. 5 pi over 3, however, if we just use the one from before, because I don't want to draw it out again, we're just going to use one more of those little slices because it's still pi over 3. It's just one more of those. And our reference angle this time is actually also going to be pi over 3. So all of these are pi over 3. But this one in particular, it's in the quadrant that cosine is positive. So in this case, this will be equal to positive 1/2. Now, I get it. That might have been very complicated for you to follow. So let's do this on Desmos. Now, I've gone ahead and I've erased everything that looks complicated, and I've just kept the values that we've come up with. Now, we're going to check if we were right. All we have to do is go to Desmos and type in cosine of pi over 3. We get 0.5. Let's put it in a fraction format, and it's 1/2. So that's what we're trying to find again, and we're just going to type in the other ones. Cosine of 2 pi over 3 is negative 1/2, just like we found before. Cosine of pi, remember I said it's not even going to be close, and as you can see, it's negative 1. So no, it's not even close. Cosine of 4 pi over 3 is negative 1/2. And look at that, cosine of 5 pi over 3 is positive 1/2. So we have got the correct answer. That is the only one that matches to our first equation. So that is the easy route to figuring out the angle measures, and that would be correct. Reference angle. So remember, reference angle, that's just going to be the angle between the terminal side and the x-axis. So let's go ahead and find that out. So if we were to draw this out, negative 310 degrees will end up somewhere over here. And you might be like, well, why over there instead of on the bottom? Well, if we remember, this is negative, so it's going to go down all the way this direction, and that's going to be our negative 310 degrees, which what is left over? Remember, reference angles are always going to be positive. So what is left over here? That's just going to be 360 minus our 310, and that will equal 50 degrees. So our answer is going to be 50 degrees. Question number 5. A circle is shown where theta is a central angle. What is the exact radian measure of theta? So what is the exact radian measure of theta? Well, if we look at something and they give us bits of information, we might use an equation that is set up to use those specific bits of information. As we can see here, we have our radius and we have an arc length. So let's use our arc length formula. If you remember, our arc length that we represent by S for some reason is going to equal theta r. So now what we can do is just fill in our arc length and fill in our radius. There we go. I have filled in 1/32 for arc length, and my radius is 1/4. So now what we can do is just solve out for our theta. Times 4 to cancel out our fraction. We're going to multiply 4 onto the other side as well. Theta is going to equal 4/32, which will equal 1 over 16. So our exact radian measure of this is going to just be 1 over 16. It's not going to be pi over 16 or 1 pi over 16 because we didn't get a pi out of this. This is our answer to this question, 1 over 16. Now it says find the value of sine of pi over 4. Remember, there's two ways of doing this, either Desmos or by hand. Now, the nice thing is that we still have our trig table up here, so we can just look up what is sine of pi over 4. Well, sine of pi over 4 is going to be square root of 2 over 2. So we know the answer already is square root of 2 over 2, and if we type it into Desmos, something weird happens. Notice we get a weird decimal thingy, and we might think that we did something wrong, but that's okay, because if we look, it doesn't equal 1/2, it doesn't equal 2, it doesn't equal 1. Square root of 2 over 2 is the only thing that it can possibly equal. But even if we had similar answers here, we could just type in square root of 2 over 2 and see what that equals, and look, it matches up perfectly. So that means that sine of pi over 4 is square root of 2 over 2. But again, I would just look at my trig table, honestly. Question number 7, find the value of cosine of 90 degrees. Again, we can just go over to our trig table and look. Cosine of 90 degrees equals 0, or we can type it into Desmos and just make sure that we are in degrees and we get 0. So either way, our answer is 0. Now it says which angle measurement in question number 8 corresponds to the same point on the unit circle as the angle measurement shown. So we're looking for an angle that ends at the same place as the angle that we see here. What does that sound like? That sounds like a coterminal angle. So how do we find coterminal angles? Well, we're just going to add 2 pi or subtract 2 pi accordingly. And one of those is going to be our answer. Now to do this, I'm going to take negative 2 over 3. Now I have negative 2 over 3. What does this signify? This signifies 2 pi over 3. But remember, whatever my answer is, I can just throw a pi into it at the end. The problem, if I add pi into here, I get a weird decimal value, and I don't want that weird decimal value. So now first I'm going to add 2 pi. But remember, instead of adding 2 pi, I'm just going to add 2. And I get 4 over 3. So let's find out if that's one of our answers. 4 pi over 3. There we go. That is our coterminal angle. Question number 9. What is 5 pi over 4 measured in degrees? So either we are going to multiply by 180 over pi, or we're going to multiply by pi over 180. Now, degrees, radians, generally have a pi value in there, which means that we're going to want to get rid of that to change it into degrees. So if we have 5 pi over 4, we're going to multiply by 180 divided by pi. Now, that's something we can just type into our calculator. The pi's are going to cancel out. This is going to be 900 over 4, which that is going to equal 225 degrees. So we have our answer, 225 degrees. Question number 10, what is measure in 70 degrees radians? Okay, that's a weirdly worded question, but you understand what it's asking. It wants us to convert degrees into radians, the opposite of what we just did for the last one. So if we took the last one and multiplied by 180 over pi, this one we're going to multiply by pi over 180. So that would be 70. I'm going to put it over 1, and I'm going to multiply that by pi over 180. All I have to do is just do 70 divided by 180. 70 divided by 180 in a fraction form is going to be 7 over 18. So this should be 7 pi over 18, and look at that, we have our answer right over there. The general form of a sine function is given below. So that's going to be f of x, or that function of x, is going to equal blank sine something x plus something else. Okay, which could be done in order to construct a sine function whose domain is all real numbers and whose minimum and maximum values are -4 and 4 respectively. So that means if we have a sine function, remember how we have our midline, and then we have our maximum values, and we have our minimum values. How do we get it to where our maximum is 4 and -4? So what does that make our amplitude? Well, if our midline's right in the middle, our amplitude is going to be 4. So what is our amplitude? Where do we find our amplitude? That's going to be box number 1. So we're going to put a 4. We're going to make our amplitude 4 by placing 4 in box number 1. Okay, a couple things here. I accidentally already clicked midline, but that's not necessarily the correct answer, and I don't know why my computer is putting pinned there. So deal with it, I guess. So the number 4 describes which aspect of the function's graph. Now we're adding, which means this is either going to be our h value or our k value, which means that it's going to either go up or down, or it's going to be our phase shift going right and left. Now, if it was inside of parentheses, this would be our h value, which means that it would be a phase shift or horizontal translation. But in this case, it's going to be our k value, which goes up or down. Okay, I accidentally clicked the right answer because that's going to be our midline. It's going to tell us exactly where our midline is based on that value. So our midline is going to be at 4. Question number 13. The amplitude of a cosine curve is 0.5 and the period is 3 pi. Which function could describe this curve? Now, if the amplitude is 0.5, that means that this breaks it down to only 2 options here. Our 2 options are only going to be the top 2. The reason being is our amplitude is our a value, and the only ones with a values of 0.5 is the top 2. So now we need to know, is our b value 1/3 or 2/3? Now the period is 3 pi. So our period is going to equal 3 pi. We also know that our period is going to be 2 pi over our absolute value of b. Or in this case, let's just use b. Now again, we also remember that our period is just 3 pi. So let's trade out our p with 3 pi. Good, now we can just solve out for b. We could cross multiply and say b times 3 pi equals 2 pi, and then divide both sides by 3 pi, and that should give us our answer, especially because our pi's cancel out. So we know our b value is going to be 2/3. So our correct answer is going to be this bottom one with an amplitude of 0.5 and a b value of 2/3. Wait a second. I just realized I forgot something. Okay, that's so much better. Question number 14. If sine of theta equals 1/2, what are the possible values of tangent of theta? Now, the first thing that I would do when thinking about these trig functions would be to draw out our unit circle and find out where would sine be positive. This comes in when we say all students take calculus. This is where each of the positive things are. The top right, everything is positive, which means we could have something over there. And the top left corner is also a place that sine could be positive. So the question would be to find our reference angle. Our reference angle is actually pretty easy to find, being that we have a trig table. So the trig table dictates if our sine of theta equals 1/2, that means we are dealing with pi over 6. So this reference angle here is going to be pi over 6, and this reference angle right here is going to be pi over 6. So now what we want to do is we want to find the values of tangent that correlate to both of these pi over 6 values. So we look back at our trig table, and tangent of pi over 6 is square root of 3 over 3. So this is going to be square root of 3 over 3, and this is also going to be square root of 3 over 3. Now, here's the thing. In the top right corner, everything is positive, but in the top left corner, only sign is positive, which means if this is a tangent function, this would be a negative square root of 3 over 3. Now you look at your answers and you don't see anything that looks the same. You might even choose B, being that it looks closer than the rest. However, here's where I have to apologize to you. We've been telling you guys to rationalize your equations this whole time. Every time that you get a radical on the bottom, we want you to rationalize it. But in this case, the correct answer is the correct answer, but it's just not rationalized. It should be, but I apologize that it's not. If you were to rationalize A, it would look like square root of 3 over 3, the positive and negative version of that. But this is just the unrationalized version of the correct answer, and I don't know why they did that. Question number 15 says identify the function that corresponds with the graph. So we need to find information about our graph and apply it to a function. Now usually I would say that the best way to do this is just to be building a function and see which one matches. But we can correlate some of the things. I would say the first thing to look at would be the amplitude, because that is really easy to look at on the graph and in our equation. So let's do that right now. Our amplitude, it seems like our midline is right at the x-axis. So the amplitude is going to be how high it comes off of the midline and how low it comes off of the midline as well. And that answer seems to be 0.5. So that is going to be our amplitude. We are already down to 2 answers. We have a 50-50 chance of getting this correct. The only difference between these 2 answers is if it is sine or if it is cosine. There is a fundamental difference on how these functions look. Sine starts at the midline and then goes up from there, whereas cosine starts at the maximum and then goes down from there. If we look at the graph, it does indeed start at the maximum. So my bet would be this is a cosine graph. Question number 16, if tangent of theta equals negative 1/2 and theta is between 90 degrees and 180, what is cosine of theta? Now, what you're going to immediately realize is that when we draw out this, we're looking for a place that tangent is going to be negative. So using our all students take calculus, we would understand that our tangent will be negative in the bottom left quadrant and the top left quadrant respectively. We would be trying to find the angle that you would place inside for theta for tangent to equal negative 1/2. But the problem is, when we look at our trig table, there's nothing that makes tangent equal negative 1/2. So we're going to have to use a tangent inverse function. If we were to have a tangent of some type of angle, which we do, and it equals a value like 1/2, we could find the angle that we would place in there by canceling out the tangent. We would do that with a tangent inverse function. But we would have to do that tangent inverse to both sides. It would cancel out the tangent and we would be left with whatever theta equals. So first of all, let's find that out. We want the tangent inverse of negative 1/2. All right, so we do so and we get this weird negative decimal value, which is fine. But remember, we're looking for a value that is between 90 and 180. So we know that the terminal side is going to be this one. It's not going to be this one down here. It's going to be this one up here. So if we looked at the value that it gave us negative 20 something. So it gave us this angle there. We don't want that angle. We want the other one. And it looks like there's a straight line that goes from these terminal sides. So that means that it is 180 degrees apart. If I add 180 degrees to my negative angle, I should get the other one that is between 90 and 180. So I would take this plus 180, and look at that. I get 153 point blah, 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 which is between 90 and 180. I don't care how ugly that looks. I just care about what the cosine of that thing is. Okay, so I get a negative decimal thing that looks even uglier, but that is fine because I can just type in my values that I have here. I'm going to try this top one here. Negative 2 over square root of 5. Okay, so I have stumbled across my correct answer right away because I get negative 0. It's the exact same one as that one. So this is my correct answer. So I would choose this one to be my cosine of theta. So we have gone from a very confusing question to a super simple one. It says find a degree measure that is equivalent to 5 pi over 12 radians. All we're asked to do is convert the radian measure into a degree measure. Now we're going to do that by taking our radian measure, which in this case is 5 pi over 12, multiplying it by 180 divided by pi, and see what that equals. Our pi's cancel out. This is going to be 900 over 12, which simplifies to 75 degrees. So our answer would just be 75 degrees. Our last question, question number 18. It says find the amplitude if exits and period of each function, and then it wants us to find our midline as well. It's a poorly written question, but I'm positive if you were to see this on a test, you would understand what you would need to find. You would need to find your amplitude, period, and midline. So let's try and find those three aspects of our graph. Now, amplitude is probably the easiest thing to find because that's just going to be our absolute value of A. Now, in this case, our amplitude is going to equal 4, not negative 4, because we're trying to find the absolute value of it. So negative 4, if you take the absolute value, turns out to be positive 4. So our amplitude is going to be 4. Now, our period, that's going to be based on our B value. But specifically, it's going to be 2 pi over our absolute value of whatever our B value is. So P is going to equal 2 pi over 2, which the 2's cancel out. So our period is just going to be pi. So here we would put pi, or pi would work as well, I believe. Or she might also be looking for the 360 divided by that, so you would just do 180 degrees in there. Midline is based on that k value, that minus 6. Now, minus 6 is telling us that our graph is going down by 6 units, which means our midline is going to be at y equals negative 6. Now, I have a creeping inclination that the correct answer here is just going to be for you to put in negative 6, which technically is incorrect. You would need y equals negative 6, but I don't know what the correct answer is here, so just take your chances on which one that you want to put. But we are done. That is the end. I hope you do well on your test, and I really enjoyed this year, and I hope that you guys remain safe, and I hope that I'm able to one day actually see you guys again.